Recently, I was working on a loading template and I wanted to simulate a slow network, and I ended up making a component to do this. So I want to take you through this process right now. So here I have a page that lists all of my blog post tags, and you can see when I refresh this page, there's a loading template that gets shown. A bunch of gray bars get rendered, and then when the data comes back from the server, it gets filled in here. And we're using Mirage to simulate the network here. And in Mirage, we've coded a 200 millisecond response time for all of our API requests. And you can see that when I reload this page. If I want to test this loading template, I can use Mirage's server.timing object to slow down the page. So I'm going to say server.timing of 1200 milliseconds. And then now if I click to another route and then come back to tags, you can see that loading template stays rendered a lot longer for 1200 milliseconds. And this is a great way for me to have more time to see my loading templates. The only issue with this is Mirage's configuration is local to this JavaScript on the client. So if I refresh the page, well, server.timing goes right back to 200 milliseconds. This makes it hard to see what the initial render of the app looks like on a slow network, since it's always going to be set at 200 milliseconds. So one thing we can do here is we can store this server.timing value in local storage. And that way, when the page loads, we can pull the value out of local storage and have this value persist across reloads. So the server.timing is currently 200, and I can do local storage. I'll do set item. I'm just going to call this timing. And let's start it off at 1000 milliseconds, so 1 second. Now, if I reload the page, Mirage is still using 200 milliseconds, but I can do local storage.get item timing, and this should be set at 1000 seconds. So let's now change our Mirage config to use this value. Right here is where we're setting the value. So we'll change this to window.localStorage.get item timing. And then we'll say or 200 milliseconds just in case this value is null. So there's one thing to know about local storage here. Everything that gets stored in local storage gets serialized as a string, and Mirage's server.timing is expecting an integer. So we need to force the type of this value, which we know is going to be a string, into an integer. And we can do that by prefixing it with a plus sign. That's going to tell JavaScript to convert this string into an integer. So if I save this and reload the page, I can see that template is rendered for a full second. So that's pretty cool. I can get my whole site to be slow, even on initial loads and reloads. Now, if I click around our site, we can see that every single route is going to take a second to load. And this is pretty cool. I get to actually see what my site looks like with the slow network. The only problem with this is that if I want to go back to a fast network or a slower network, I'm always going to have to come over here and run local storage, set item, timing. Let's bring it back to 100 milliseconds. And once I reload the page, I can see it's much faster now. So I can visit the tags route. Loading template's only rendered for a fraction of a second there. Back to blog posts and tags again. So this works, but the ergonomics aren't so great having to manually access local storage. So I thought it'd be pretty cool to make a component that is going to give us direct access to this. So let's get started on that. I'm going to come over to the components directory, and I'm going to create a new component called speed control. And this is going to be an Ember component. While I'm setting this up, I'm also going to create the components template. And then I'm going to render this component in my application template. Let's hop down here to the bottom of the file, and I'm just going to put speed control right here. Okay, so let's start by working on the UI of the speed control component. I'm going to create a div here with absolute positioning, and I'm going to put it in the bottom right of the screen. I'm using these Tailwind classes here to position this element, and we'll just start with these for now. I'm just going to give this a nice title of speed control. And then inside this component, I'm going to use an input with type range to control the speed. Let's save this and see what it looks like. Okay, and there we go. We can see our speed control component being rendered down here. And yet the plan for this is that as we move this slider, we'll be adjusting the server timing. So you can imagine this would be really fast, 0 milliseconds, and the far right is going to be, let's say, 10,000 milliseconds or 10 seconds. I'm going to go ahead and split my screen here so I can do both the component as well as the template at the same time. So the first thing I want this input helper to adjust some timing. So I'm going to say this is value, and this value will be bound to this timing property. Now over here, timing is going to be a computed property, and the computed property is going to be both a getter as well as a setter. So when we get the property, we're going to read right from local storage. So we'll say return window.localStorage.getItem timing, since that's where we're storing this. Now when we set the property, we're going to want to put it back in local storage. So we're going to do window.localStorage.setItem timing, and then we're going to use value. And value is a variable that gets passed into our setter. Our setter is going to take 2 arguments, key and value. And with these computed properties, when you do the getter and setter computed properties in Ember, you need to remember to return the value out of the setter. This is important for Ember to keep track of the value that you just set. And we need to fix up this syntax by adding a comma. And then we also need to jump up to the top of the file and import computed, since we're making a new computed property. So let's check out how this is working. So we're not getting any feedback here. We're not sure what's happening as I drag this slider. So let's go ahead and add that timing variable to the template. Come over here and we're just going to render timing. And there we can see the value is 100, which is the last value that I set with the console over there. So now let's see what happens when I drag this. And so our timing isn't getting updated. The input is not updating our timing variable. So it looks like this set over here is not getting invoked. And that's because we're working with a regular HTML element here, and we need to use the DOM's onInput event. And we'll use this to trigger an action. So we'll say action update timing. And then back in our component, let's go ahead and add that action. Say update timing. Because we're using a closure action, our action is going to get passed an event as its first argument. And now we can invoke the setter on our computed property. So we'll say this.set timing. And the way we get the value of that range input is we're going to get the value from the DOM event. So we're going to use event.target.value. Save our work. And now we see our timing variable update. And if we come over here and we do window.localStorage.getItem timing, we see 42. So that's pretty cool. And we should be able to refresh the page, see a super fast load, and do server.timing, and we see 42 because Mirage is going to read right from local storage. So the next thing I want to take care of is 0 to 100 milliseconds doesn't really let us test a loading template. So let's go back over to our range input. Let's add the attributes to make the slider be able to select more numbers. So the first attribute is min, and we'll do a min of 0. Then we're going to have max, and we're going to do 10 seconds as our max time, so that's going to translate to 10,000 milliseconds. And then there's also a step attribute, which is how much to increment and decrement the value by as we move the slider. So we'll step through these values by 100 milliseconds. let's reload this. Okay, and I can come down to my slider, and there we go. I can make it go all the way up to 10,000. I think a better Ember developer would have made it go to 11,000. And we can see that Mirage is using this value. My loading template is going to stay rendered for 10 seconds here. Pretty cool. And if I click around the app, I can see that the blog post route is also going to take 10 seconds here to load. So this really lets me know how my Ember application is performing with a really slow network or really bad network conditions. And I can drag it back down so I can make the site fast again. Go to tags. And this is interesting because we're still using that slow 10-second timing. And if I do window, local storage, get item, timing, I see 0. But if I do server.timing here, I still see 10 seconds. And that's because if I come back to the Mirage config, I'm setting the timing when the config initializes. And as I change the local storage item, there's no live binding here. So Mirage doesn't know that this item is changing. And so Mirage just remembers the value that was set on page load. So let's work on making Mirage update as I drag that slider around. So the easiest way to do this is in our setter. We can do server.timing equals value. And in our apps, we always attach the server to the window object. So this makes it accessible everywhere in our application. So it lets us have these components get direct access to the server. And again, with Mirage, it wants its timing value to be an integer. So we have to come over here and we're just going to add a plus sign to force this value as an integer because we're not sure what's exactly is going to come out of that input element. Okay, let's give this a try. Let's go for about 3-4 seconds. Click blog post. 1, 2, 3. Nice. Let's make the site fast again and go back to tags. And there, look, instant. So this is a great little component to help us really test our loading templates to see just what our site looks like. So one thing I noticed here is that if I go this blog post route, the speed control gets rendered down here, but it doesn't look good. It shows up over the other blog posts. So I want to clean up this code a little, clean up the styling here. I'm going to come up here to this top div, and this is where I'm going to start. So the first thing I want to do is I want this control to take up a good bit of the bottom screen. I'm going to take up about 60%. I'm going to give it a background color of white. And I'm going to give it some padding so it's not just pushed into that bottom right corner. So we'll say padding right 4, padding bottom 4. And I'm going to give it a blue border and a border width of 2. And then also give it a shadow so it stands out from the rest of the page. Let's take a look at what this looks like. Okay, and now our component is a bit more visible. I think I'm going to need some margins here to lift it up. And then this H2 looks like it's taking up a good chunk of real estate. So over here, I'm going to do margin right of 4 and margin bottom of 4. And I'm going to change these paddings to be 3. So give it a little bit less padding. And you know what? It would be better here to do padding all the way around. So that's going to be P3. And then I'm going to clean up that H2. So we'll say class margin 0, padding 0, and then finally margin bottom 3. Let's save. And there we go. That's looking a little better. It's taking up a bit too much of the screen. I think 3/5 or 60% was too much. So let's drop this down to 2/5. And this is how we do 40% in Tailwind. Yep, and that looks a little better. And then my range selector, I think I want this to expand. I think that I want this to take up more real estate in this little pop-up here. So I'm going to wrap it in a flex div. I want everything in here to line up, so I'm going to do item center. And then this timing is going to need to be wrapped in an element, so I will wrap it in a div. I'm going to put milliseconds here so it's clear what our unit is. And then because I want this input to take up a majority of this flex container here, I'm going to do a class of 4/5 or 80%. So the input will take up 80% and then the timing will take up the remaining 20%. Nice, so that looks better. Let's make sure I didn't break anything here. So this is strange, there's some wrapping here. I'm gonna go ahead and close the console. And so this looks a little better. So now let's make sure it actually works. So let's go to 5 seconds. And here we see our tags route loading. And that was about 5 seconds. Let's bring it back down to 0. That was instant. And now our tags route loads instantly. Cool. If only all networks could be this fast and make our jobs so much easier. Let's do one last thing and make this timing div line to the right. And because we're in a flex box, we can use margin left auto and it will push this div over to the right. And if I reload, there we go. So I'm pretty happy with how this looks. And the best part is we can bump this up to say 4-ish seconds. And we can see what our page looks like with a 4-second delay on initial render. Pretty cool. So I always like taking the time to go the extra step and make components like this. You know, when this video started, we pretty quickly had the ability to control Mirage's server timing using local storage directly through the Chrome DevTools console. But the reality is if I have to open up local storage to adjust the server timing, I'm probably not going to do it that often. But if I make a component like this that's rendered on the screen, that's just kind of right in my face, I'm always going to be adjusting the timing. It's a reminder that I need to test my loading templates on a fast connection, on a slow connection. So I really like having components like this. And you know, Ember is really great at making our users' lives better through all the powerful UIs we can build. But we can also make our lives as developers better by building components like this. So this is just a little example of a small quality of life component that you can make to see how your site performs under different network conditions.